Yes, 1, 2, 3. And I will share my screen. Okay. I guess we are now live. So hello, everyone. Thank you for joining us. Welcome to the first additional day of the .NET Fwdays online conference. We are happy to have you with us today. So today will be a discussion with Kevin Gosse, staff engineer at Datadog, and also there is a moderator here, Igor Fesenko, solution architect at SoftServe. And on June, there will be a workshop on can my .NET application use less CPU RAM? We invite you to join. And if you have a full ticket, you can watch recordings of additional formats for another 3 months. And on Saturday, there will be the main day of the conference happening. There will be 2 parallel streams of talks in the Ukrainian track. The talks will be in Ukrainian language and in an English track in English. If you have just registered, you can only watch all the talks during the conference. But if you have a full ticket, you can also watch the recorded talks right after the conference and for another 3 months after the end of the event. So join. We would like to thank our program committee, Anton Boyko, Andrei Krupsky, and Sergey Belsky and Igor Fesenko. All this time, they helped develop the program and find the coolest speakers. Your help is truly valuable, and we very appreciate this. Our conference is supported by our gold partners. These are outstanding companies. There are 3Shape, ErgoPlace, Falcon, and English Dome. And August 12th, we will hold PHP Fwdays conference, the largest and the most popular Ukrainian conference for PHP developers. And on September 19 and 23, a conference devoted to practical issues of software architecture will be held. Software Architecture Fwdays 23. And the conferences will be in online and offline format in Kyiv. So join. And registration on another conferences and our events is already open as well. So you're welcome to join also. And we have a Telegram chat where you can ask any questions to Kevin today. And we will discuss it as well in the end of discussion in the end of the day when we will have time. And we have a chat bot also. So if you subscribe to it, you can receive a real-time announcement and news about the conference on Saturday. So join us and stay tuned for everything. So I guess we can start. And so welcome, Kevin and Igor.
Okay, yep, let's start. Thank you so much for introduction. And Kevin, thank you so much for joining us. We prepared a lot of questions, and also you see that we have more questions coming, and I tried to blend them into our discussion, into our agenda. So before we start with a bunch of questions, I'd like to ask about your current Datadog work and what are your main area of expertise, because probably not everyone knows you and maybe even not follow on your social media. So if you can describe in a few words about your Datadog and what do you do for Datadog?
Sure. Yeah, first, thanks for having me today. So I've been working at Datadog for the last 3 years as a staff engineer in the .NET APM team. So basically, I work mainly on the .NET Tracer from Datadog, and I've also worked a bit on the continuous profiler. And so the goal components is to automatically collect traces and profiles about your application without having to do any modification to your code, and then send them to the backend, and we display them in a nice UI. And so I'm mostly focusing on the performance and reliability aspects. Aside from my work, I try to publish some articles on my blog when I have time. I'm not very consistent with that. And on it, I talk a lot about debugging mostly, because this is one of my passion, and something that I have to do a lot through my work.
Wow, cool. Yeah,
Yeah.
and by the way, yes, you have Twitter, you have your blog, and you publish some interesting post about your expertise, daily work. And what is most your recent challenge, or maybe some I don't know, complex task that you resolve it successfully? And what is the most recent experience? Yeah, with
I think well, so in general, my most recent challenge is actually there would be two. I'm trying to write a profiler in .NET, though that's not part of my Datadog work, because I don't think that would be viable in our products. But this is a nice pet project, and for one, it's a good way to get more familiar with all the interaction between native and managed code, and also what new possibilities native AOT is bringing to .NET. And also, I'm hoping that it will be an opportunity to make the more accessible, because right now, since you can only write a profiler in C++, a lot of people won't even try it, even if that could be useful for some custom tools. And the other challenge that I'm busy with right now is there is Konrad Kokosa, who is the author of the .NET Memory Management book, that has contacted me and Christoph Nazar, who is a coworker and friend, and asked us to help him write the second edition of the book. So it's a 1,000-page book about memory management in .NET. So it's quite a bit of work to review it, update it, and update it with all the novelties that have been introduced in the latest version of .NET.
Yeah, and yeah, we also had this question in our agenda. First of all, congratulations. Now you're co-author of this amazing book, and I think a lot of people read this book. So, and we're eagerly waiting for a second edition with your improvements. And I saw your Twitter that you try to simplify and streamline, and even deleted some pages. So, because it makes sense. Yeah, and thank you for your dedication with that. And what do you think about this experience now, writing book and trying to explain and structure your knowledge? How do you feel about that? Is it challenging, or maybe you regret about this decision to step in, or what are you feeling right now?
Yeah, I've been considering writing a book for a long time now, because I love writing, and that's one of the reasons why I have a blog. But a book is a huge time commitment, much more than just writing articles whenever I have time. And so for a long time, I've considered writing a book about debugging, because that's really the subject I'm passionate about. But I just couldn't find the motivation for it. And so it was really nice that Konrad contacted me for that, because I would say it's slightly easier than writing a full book because we already have the bulk of it ready, and we just have to make additions and transformations and so on. And also there are 3 of us on it, so it's much easier to motivate each other whenever the motivation is low. Yeah. So yeah, definitely a major challenge, mostly a time challenge. And those are the difficulties that we have is, so I'm saying that it's easier because we are 3 people on it, but at the same time we have 3 people with very different styles, and so it's a bit hard to merge them into one consistent whole. So we will see what the result will look like. And yeah, who knows, maybe if everything's go well, then I will finally decide to write my book about debugging. We will see.
Wow, yeah, and I think it's a very smart start with existing one, yeah, and just incorporate your knowledge and do review. And for our audience, just to highlight, because sometimes they say, okay, main motivation to write a book is money. No, it's not about money.
Yeah.
It should be some other motivation to write a book. So please consider this. And what is ETA? When the second edition is coming available?
We are targeting the end of the year. It would be very nice if we could release at the same time as .NET 8, but that's unlikely. So it's much more likely that it will be in December or even January next year.
Okay. And by the way, regarding .NET and C# language and .NET 8, and what about future of C# and .NET platform? What are your feelings about .NET and C#? Do you look to another language, popular language and popular runtime platforms, or you still believe and trust .NET and C# and you're passionate about this platform?
Yeah, so yeah, I think the future of .NET is very, very promising. The move to open source with .NET Core was really needed, and so it's great that Microsoft did that. And right now, .NET is evolving as a very fast pace. Many people actually think that it's evolving too fast. And they are doing a great job at making it available on other platforms. So I'm thinking about Linux, I'm thinking about ARM. So that's really nice. And then you have some very innovative components such as native AOT that will allow to use .NET in many new scenarios. So yeah, I think the framework is in a really good place right now. One of the main area of improvement that I would like to see in the future version is the size of the binaries, because when you compare to Go, for instance, the .NET binaries are huge, and that's a problem when deploying in containers and this kind of stuff. But the runtime team is aware of that, and they are working on improving this with every version. And then I'm looking a bit at Rust, like a lot of people, I think, because Rust is in that nice place where it's very low level while still providing type safety and memory safety. Actually, there are a lot of teams at Datadog that are working on Rust, but I'm very, very far from being efficient with Rust, because this is a language that has a very difficult learning curve, and so far I didn't have much time to spend on it. But that's clearly one other language that I would like to add to my skills.
Yeah, Kevin, and what do you think about .NET tooling and tools? We have profilers, we have a lot, and you started to write your own profiler. And what do you think in future, can we use C# language to write low-level tooling like profiler instead of C++ and unlock this power of managed language, managed runtime? What do you think?
Yeah, so that's really. I'm really hoping that it will happen, and I'm trying to make it happen on my side. So that's the reason why I'm working on writing. I'm working on writing a profiler in .NET. In the past, I've also tried working on some low-level tools for Linux, all written in .NET. So the capabilities are there. I guess some people could argue about how useful it is, because if you are going to write low-level stuff, then you're going to need some very specialized knowledge. And if you're going to acquire this very specialized knowledge, you may as well learn C, C++, or Rust while you are at it. But at the same time, I really like C# and how it allows you to build stuff very fast. And so, yeah, I'm really hoping that there will be more improvement on that side, and that Microsoft will continue to push native AOT.
Yeah, and you are a well-known person with this low-level experience and practice and all your presentation. And I personally follow you on Twitter just to see blog posts and your findings, some cool stuff. And how did you start with this low-level programming? Because it's not just about your like a hobby or something like that. You also had projects where it was required to do this micro optimization just to save milliseconds, because at scale it saves hours, so even days. Oh, how did you start with this low level things?
Good question. So from my very first professional experience, I was in charge of an application that had some memory issue. It was back in the .NET 1.1 days. And so very, very early, I had to start learning how memory management works in .NET, and how to use some tools like WinDBG to dig into the memory and understand why the application was throwing out of memory exceptions, even though there was still some memory available on the machine. And so learning about memory fragmentation and all this kind of stuff. And it kind of served me in my next professional experience. But the real change was when I joined Criteo. I think that was about 8 years ago now. And Criteo works at a massive scale, processing hundreds of billions of requests per day. And so it's really pushing .NET to its limits. And at Criteo, I was working on the framework team. So basically, we were building the framework that was used by all the services at Criteo. And the thing is, most developers, when you write a normal application, you have a lot of you have a lot of work to write your business algorithm. But whenever you need something technical, you're just going to find a library and integrate it. When we work at the scale of Criteo, the libraries that are available break. They are not designed to handle this level of scaling. And so we had to rewrite libraries for everything. And even something that seems easy, like a producer-consumer queue, suddenly becomes a challenge, and we had multiple queues that were optimized for very different scenarios. For instance, optimized for having just one producer and many consumers, or the opposite, and so on. And so you start to understand how everything is a matter of compromise, and the more features you add, usually as you add more features, you're going to reduce the performance of your libraries, and so you have to make more specialized components. And so that's where I learned a lot, mainly about performance. And also another thing that happened at Criteo was that I had this past experience on WinDBG. And I told my manager that because I was seeing that many teams had issues with were struggling to diagnose bugs in production, and I told him I have some experience with post-mortem debugging, and so I can help them if you want. And so the next time there was a bug, the manager gave it to me, and after 1 or 2 weeks of investigation, I managed to solve it. And so then there was another one, and then months afterwards, I became the debugging guy at Criteo. And so from that point, I was spending about 50% of my time debugging production issues for other teams. And so that's where I really ramped up on the subjects, and when I started developing my own tools, because when you debug a memory dump once or twice a year, you're not going to invest a lot on it. But when it's 50% of your workload, then it suddenly becomes very interesting to develop new tools to make your future investigations faster.
Yeah, and I think at this moment also you started with public speaking, and NDC Oslo conference, if I remember correctly, it's first time when I saw that someone explains WinDebug to the public, to audience, and see this is our experience, and we work at scale. So yeah, it was great and motivational presentation regarding this. And do you use WinDebug right now at Datadog, or it's another
Yes,
level?
I do.
Okay.
Especially so the .NET APM published by Datadog relies on the .NET Profiler API. And so today you can only write profilers in native code, which means that we deal a lot with native code. And even more importantly, we deal with native code that calls into .NET code and the other way around. And so to debug this kind of stuff, you usually need to use low-level debuggers like WinDBG. So that's one of the reasons why I keep using it. And the other one is that the developer teams at Datadog are doing level 3 support for customers. Well, whenever a customer has an issue, it's often very, very difficult to reproduce it, because every customer has their own setup. And so asking them a memory dump is a very good way to gather everything all the context and all the information about the bug that you need inside one single file. And it saves a lot of time for everybody. And so I keep digging into a lot of memory dumps for support, for customer support.
Yeah, and also, if you don't follow Kevin on Twitter, you probably missed cool, I would say, some hack. You use environment fail fast in exception in catch just to create snapshot of dump. It's very smart, yeah, and it's cool. So I like this idea. And do you have some other hints or tips how we can easily take memory dumps, system dumps, and also use WinDebug tool and for this just to streamline our entire experience, because there is a lot of documentation, I would say, and how we can keep up our knowledge up to date and get more additional information for this tool.
Wow, that's a very difficult question. Yeah, that's very broad. So to capture memory dump, you usually use proc dump on Windows, and on Linux you can use .NET dump. That does a good job for that. What can I say? One thing to know is that on .NET Core, you can set an environment variable so that your application will automatically capture memory dump when crashing. So that's a very convenient way to capture memory dump. And then once you've set that up, you can also do the kind of tricks that you mentioned, that for instance, crashing your application on purpose just to capture memory dump. Yeah, and overall, if you want to get better on the subject, that's very broad. Well,
Maybe you can share your experience. How did you start? Because even I would say 8 years ago, I don't remember about documentation or GitHub repo with explanation, this book of runtime or how WinDBG works. So how did you extract this knowledge and get this knowledge?
What bootstrapped me into the subject was the blogs of Sasha Goldstein and Tess Fernandez. They are both very, very, very good sources of knowledge about debugging. I mean, they are written to be understandable from beginners. So that's why, especially the blog of Tess Fernandez. So that's why it's a very good place to start if you want to learn more about it. Yeah, and then from there it's mainly try and error. There is an excellent book which is Advanced .NET Debugging, which focus, as the name indicates, on .NET debugging. But it's quite old and is for .NET Framework. So I think an update would be needed. I don't know if any new book has been released on the subject since .NET Core. Yeah, and apart from that, it's mostly curiosity. It's mostly you need to be willing to dig into things and try to understand how they work. And it takes time and a lot of trial and error. I wish there was a secret recipe so that you you quickly learn about it, but unfortunately we're not quite there yet. With the rise of AI, maybe tomorrow we will have better ways to guide new developers into debugging. As a matter of fact, as a pet project, I've been playing with creating a GPT-based assistant for WinDBG with, I would say, pretty good results for a first version. So that's very promising, and that's actually something that I wish I will be able to pursue at Datadog. We will see. We will see how things goes. But yeah, today there is unfortunately no secret. One piece of advice that I would give is that most people stop because they are afraid of the tooling. but they don't realize that tooling is not the hardest part. What is very important is that for the people who haven't seen my presentations, basically, I tend to apply a precise methodology when I do debugging, which is 3 steps that I repeat. So the first one is to gather data about your program. And then the second one is to understand this data. So basically put this data into context and try to formulate a theory about what is going on in your application. For instance, you know that your application is not responding. Maybe it's a deadlock. That's one example of theory. And then the last step is to try to verify your theory. And more often than not, you're going to realize that your theory is wrong. But by finding out why it's wrong, you're going to gather more data that will help you repeat the cycle. And every time you will make more refined theory, and eventually you will manage to understand what is going on with your application. And the thing is, in one of those steps, as an understand step, when you're going to make a theory, no tooling is involved at all. And I believe this is the hardest step. Basically, knowing the symptoms of the problem, trying to get a mental image of what is happening. And I don't think that's something that you can learn from books or online documentations or whatever. It's really something that comes from experience. And I believe that's the hardest part of debugging. Once you know what you're looking for, so for instance, I think it's a deadlock, so I'm going to inspect the stack trace of the thread. From that point, even if the tool is hard to use, you should be able to find online tutorial about how to do this specific task. But people tend to get lost because they expect that they will find a sequence of commands that they can run and it will solve any bugs, but that's not how it works at all.
Okay, so and it definitely makes sense to have some Copilot or ChatGPT plugin to WinDebug because, yeah, it makes sense. And with this new AI era, we definitely need to have some plugin and make sure that I don't believe that it might resolve our issue and find. Probably, if it is simple scenario and this is memory leak, if you just forgot to free memory or you have some reference, but for some complex scenario, it might help and just point to right direction and propose options. Yeah. And C, still we have a little demand, but I would say in future we have huge demand and we need to motivate you to write this your book regarding advanced techniques for debugging. So definitely. And we have a question from our audience. I think it's related to my next question. Question is, how do you feel about assembler and what is its place in modern development from your point of view?
Wow. Well, to write programs, I think knowing assembler is pretty much useless. There are a few programs where even today you're going to need to write a few lines of assemblers, but it's very rare, and you can just either find somebody to help you or just learn about the little bit of assembler that you will need at that moment. However, for debugging, and especially if you need to debug native code, then knowing assembler is a great asset. So that's not something that you usually need when debugging .NET code, fortunately, I would say, mostly because you can debug most issues at the C# level or at the IL level. And if you are at the IL level, there are great decompilers out there. So you don't really need to get any lower than that. But if you start doing native development in C, C++, Rust, or anything else, then knowing assembler will greatly help you to debug your issues. And I would strongly recommend learning some. Not trying to be an expert and somebody who is capable of writing programs in assemblers, but at least knowing about most common instructions and what they do, basically.
And I think it's similar that WinDBG is a tool, I would say low-level debugging. And what do you think about high-level debugging? For example, also tool with good visualization and there is buttons instead of typing commands and trying to find, and also integrated with some AI assistance. It might say, okay, you have potentially, I don't know, sparse array, or you have a lot of objects of the same type. What do you think about applicability of high-level tools and high-level profilers, like from JetBrains or Ants Profiler or other companies? And I think also Datadog is also adds some capability of this dump. You can get dump, you can get inside of your application and visualize them. So what do you think about that? When we need low level and when we need high level profilers?
Well, you should always start by trying to find a high level tool for your problem, and basically switch to low level if everything else failed. There are great tools available. So for starters, Visual Studio have a lot of features available, and I think many people don't spend enough time learning them, which is a shame because it's really going to save you a lot of time. Basically, when we talk about developing application, we always think about writing code, but we tend to forget that debugging the code is easily half the time that we spend on it. And so if you take a moment, take a few hours to familiarize yourself with all the debugging features that are available in Visual Studio, it will definitely pay off and save you a ton of time in the long run. There are features like make object ID in Visual Studio that almost nobody knows about, but once you know about it, it's incredibly powerful. So that's one thing. You mentioned JetBrains tools. They are absolutely great. I use .trace a lot. I use .memory whenever I need to diagnose a memory leak. But yeah, .memory is very specialized, so it's great if you need to find about a memory leak. It's not so great if you have to do anything else. But that's the point of those tools. So basically, they try to focus on one special thing and they do it really well. And so yeah, you mentioned Datadog. We have some projects going on. I don't know how much is public today, so I'm not going to talk a lot about it. But at the very least, I think 1 year ago we acquired Oscode, which is a company that developed a live debugging tool, basically a tool that was capable of, for instance, whenever you have an exception in your application, in your cloud application, it's capable of automatically understanding that it needs to instrument this method so that the next time you have an exception is going to capture the state of the variables around that exception and then display that in the UI, so that you have a very similar experience as if you attach a debugger, but it's going to happen asynchronously. And so we are developing similar tools for Datadog. So I don't know how much of it is already available and when it will be publicly available. I don't really know, but there is a lot going on behind the scenes.
Yeah, and regarding Datadog and instrumenting your application with some SDK for this application performance management and profiling, I would say production. From my experience, I met teams that mention, okay, we cannot integrate Datadog or another APM tools because it adds a lot of overhead. And I think that's not true. And value that you receive, yeah, of course, you add overhead because for all .NET runtime, there was no way like performance counter or integrate your SDK aside. But still, you have a lot of insight for application, but still overhead exists. And what is your I don't know how to say feeling about this overhead? And I know you try to optimize and reduce this overhead, but what do you think about this overhead at all?
Yeah.
Just is it still a valid question for 2023, because if something wrong with memory, it means that it's wrong with your application. It's nothing to do with Datadog or another APM solution. What is your opinion about that?
For starter, I would say that if you've tried Datadog, I'm only going to talk about the .NET part because I don't know much about the other language. If you tried Datadog 2 or 3 years ago and thought that the overhead was too high, you probably should try again because we've made a lot of improvements on this subject, and that's basically the reason why I was hired at Datadog originally. So basically, before I joined, the focus for the .NET APM was really on the features. And when I joined, I worked on changing the culture and really working more on performance. And so for that, we did many things. So of course, we optimized our code, but also we added benchmarks, new testing environments, and so on, so that we catch performance regressions as early as possible. And so when I joined, we did have a lot of customers that complained about performance. But I would say the past year there has been very few people complaining, and when they do, it's usually because despite our testing, performance regression still made into the final product. And so I would say that we take performance very seriously. I like to say that performance is a hidden cost that we are putting on our customers. So basically, you already spend arguably quite a bit of money to get a license to use Datadog, and then you have to pay this extra bit because we are going to eat some of your CPU. And so that's why we really try to reduce it as much as possible. And I think we are doing a fine job at it, even if it's not perfect. And yeah, and we always have some, I would say, there are always customers that have very specific setups that we didn't optimize for, but then they just contact the support, and usually we manage to find a solution. Maybe we can add a special settings for them, or optimize one part of our code that we didn't think about. And so overall, the overhead should be fairly limited. In terms of CPU overhead, it always depends on the application, of course, but I don't expect that you will get more than a 5% increase in CPU usage by adding the tracer. If you add the continuous profiler, there are still some rough edges, especially on Linux, and so in some cases you might have a bigger overhead. One thing that some customers don't like right now is that, so in many cases, performance is a compromise. You can optimize for CPU usage, you can optimize for memory usage, but it's hard to optimize for both. And we tend to optimize for CPU usage, which means that the tracer uses quite a bit of memory. And so by adding the tracer to your application, you should expect your memory usage to climb by at least 100 megabytes. For many people, it's nothing, but for people who run their application on very small containers, it can be prohibitive. So that's one thing to keep in mind if you want to use this kind of instrumentation in your application.
Yeah, and from your experience, you did a huge work to do these optimizations, and is it just Datadog code, or it also evolving of .NET runtime? For example, they exposed some API or improve it, I don't know, some areas how you can integrate and get this, for example, performance counters and get all required information without some hacks and injection into process. So, or it's just Datadog code, source code, I mean, improvement and review. From your experience, can you just highlight?
Yeah, that's actually a huge source of frustration for me, because we still support all the way back to .NET Framework 4.6.1. And because of that, it's very difficult for us to use all the novelties from C# or from the runtime that will significantly improve the performance. And so every time we are going to integrate a new feature, because it's not going to be available on .NET Framework, it means that we have to split some of our code base, which come with a significant maintenance cost. And so that's something that we don't do a lot. And I know for sure that if we could drop all this legacy and really convert our code to modern C# with spans, ref structs, stackalog, and so on, we would be able to gain a lot in terms of overhead. So, yeah, we could definitely be better.
Yeah. And we have a question from our listeners. Is it important to know the CPU architecture of the system where you debug your application? The implementation of .NET platform units depends on concrete CPUs.
Not a lot. So for starters, there are not a lot of CPU architecture that .NET runs on. So there is only 3, unless I'm mistaken. So x86, x64, and then ARM64. And the .NET runtime is doing a pretty good job at making sure that your experience is consistent across all the architectures. one example is that, for instance, the memory model of ARM is much more relaxed than the one on x64. And so stuff that you would usually do on x64 becomes unsafe when you do them in ARM, because you don't have the same memory safeties. And so very early on, the .NET Runtime team implemented additional safeguard to so that even if you run on ARM, you get similar memory safety than on a x64, even if it's at the expense of some performance. So yeah, overall, I think that it has been a priority for the .NET team to make sure that you don't have to worry about these kind of things.
Yeah, good. And also you mentioned that we have this native AUT now direction, and also this is a, I would say, big point of concentration for you, this native AUT. And can you please explain why do you believe in this native AUT, and how does this technology might solve some our problems?
Yeah, so I think that there are two aspects to this. The first one is that until now you could use .NET only .NET, either in .NET application or as COM components. And so if there is any place where any program that expects that has extensibility features and it doesn't explicitly support .NET or COM, then you couldn't write .NET code to extend it. Except if you used C++ CLI to write a wrapper to your .NET application. Now with native AOT, you don't have this problem anymore. And so any program that expects an extension written in C, you can write it in .NET with native AOT and it will work. So I think it's very nice, because it means that we can use .NET in many places where we couldn't before. And then another value of native AOT is the size of your binary for self-contained deployment. So if you want to deploy your application as a standalone tool that doesn't require to have a specific version of .NET on the machine, you can either compile it, I would say normally, as a .NET application self-contained with a runtime. But even if you enable trimming, the application will be fairly big and probably too big for your needs. And what is nice with native AOT is that because it works with so native AOT does not support dynamic execution. So all the code that is going to be executed is available at the moment of compilation. And thanks to that, the compiler can do much more aggressive trimming, and you will end up with smaller binaries. And so that, I think that's one of the key advantages of native AOT.
Yeah, it would be great to have this technology stable, because this is still under preview. Am I right?
I think it's stable now. With .NET 7, it was officially released as stable. They are investing a lot on it for .NET 8. First, so there are a few paths of improvements. For instance, they are working to further reduce the size of the binaries. They are working to add more capabilities for diagnostics. Because, for instance, your .NET profiler is not going to work on a native AOT application because it's not a .NET application anymore. And last but not least, the ASP.NET Core is working very hard to make ASP.NET Core fully compatible with native AOT. So those are major improvements that will come with .NET 8. And so it's really nice to see that that Microsoft is investing heavily in that technology, because I was a bit afraid that it was just going to be a one-shot and then become forgotten.
And we have a new question just pop up. Has it ever happened with you that certain debug or diagnostic tools were tricky during app debugging? I think it's something like false positive, or maybe they didn't work as expected. This is my understanding. The diagnostic tools were tricky.
Yeah, let's see. Yeah, well, I'm trying to find to think about specific examples, but I mean, there are times where some debugging tools didn't work for my usage. For instance, it happens a lot on Linux. I'm perpetually jumping from GDB to LLDB to WinDBG, because WinDBG now has pretty good Linux support, surprisingly. And so I'm using those three debuggers interchangeably, because one is going to be able to read this information, one is going to be able to unwind this stack, and then WinDBG is great to fetch the symbols, and then and so you have to jump from one to another, because none of them is perfect. But yeah, I don't really have specific example that come to mind, unfortunately. Yeah.
Yeah, and this is good signs that we have a great tooling for .NET platform. If we try to compare with other tools, I mean other language. So, and that's why I think that .NET runtime and development for .NET is really great, and for future. And what are your recommendations for our .NET audience? What do you recommend to check and to see, to review? What are your most recent excitements, maybe from this year or last month?
Let's see. Well, personally, my recent excitement is native AOT, obviously. But it won't be useful for a lot of people yet. As a general purpose advice, my advice would be to always try to learn what is happening one layer under the layer of abstraction you are working at. So for instance, if you are a C# developer, try to learn a bit about how the runtime works, the thread pool, the garbage collector, and so on, because it will be, well, sooner or later it's going to bite you. And so when it does, it's very nice that you are able to quickly understand what is going on thanks to that knowledge that you acquired previously. And so likewise, if you are used to work at the runtime level, then go one layer deeper and try to learn how DLL works, how shared module works, and so on. Yeah, so that's one general purpose advice that I would give. And then is there any recent feature that I'm excited about? Yeah, I don't know. It still go back to what I said earlier, that at Datadog, because of all the legacy, we can't really play with all the new shiny toys, and that's why I don't get as excited about novelties as I should be. And of course, like a lot of people, I'm very excited about the AI boom and what it will bring. And there are many people at Datadog that are scrambling to find ways to integrate AI into our products. So that's something that that will happen in the near future. And so even as a .NET developer, I strongly recommend you to play with the OpenAI API. There are many Nugget packages that allow you to easily access it. And you will discover that it's really easy to integrate into your application, and it might give you ideas about what to do with it. So yeah, even if just by curiosity, I really encourage developers to have a look.
Yeah. So, and we received thank you, Kevin, for your answers, for sharing your debugging experience and visions of .NET future. So it was from our audience. It's not a question. Yeah, and also thank you so much, Kevin, for joining us, and appreciate your times, your efforts, your speaking, your blog posts, and the co-authoring book that you doing a lot of awesome job and motivate .NET engineers. And today we had a really grateful discussion. I learned a lot, and it was interesting. Thank you so much, Kevin.
Well, thank you. It was very nice for me.
Yeah. And looks like we don't have questions anymore. So, and we are just in time. So
yeah. Thank you so much, guys, for this interesting discussion. I'm not a developer, but I was listening to you, and it was interesting for me as well. And thanks, Kevin, for your time. Thank you, Ihai, for moderation. Really hope to see you guys in next our events among speakers. And yeah, and thanks everybody for joining us, and hope to see everybody on Saturday at .NET Fwdays online conference. Have a good evening or day.
Yes, thank you, everyone.